Welcome to e-MOOC series, initiative taken by LJ Institute of Pharmacy. I'm Joshi from Department of Pharmaceutical Technology. Today we'll be learning about surface and interfacial phenomena, part 5. But before that, please like, share and subscribe our YouTube channel Pharma Ignite for the latest updates and videos. Now, first of all, we'll be discussing about absorption at solid interface. Now, solid surface, when exposed to gas or liquid molecules, absorption takes place basically in a uniform layer forming takes place on the solid surface. So, the process by which gas or solid liquid molecules get concentrated at the surface, the process is termed as absorption. The solid surface is referred to as adsorbent. The gas molecules or the liquid molecules which are getting absorbed at the surface, it's termed as adsorbate. Now, depending upon the nature of interaction between the adsorbate and adsorbent, absorption is classified into physical and chemical absorption, which is also termed as physisorption and chemisorption. Now, next is physical absorption and chemical absorption classification, or you can say difference. So first of all, physical absorption is reversible, chemical absorption is irreversible. Once it is done, cannot be reverted back. You cannot get the reactant. Now, physical absorption is having weak forces, or you can say weak van der Waals forces, but chemical bonding is having a strong chemical bond. Now, physical absorption takes place, as you can say, it is a non-specific, while chemical, it is more a specific kind of absorption. Now, physical absorption is, you can say, common at a very low temperature, while chemical absorption takes place at a higher temperature. Now, heat of absorption in the case of physical absorption is very much low, while it is opposite, that is, you can say it is higher in the case of chemical absorption. Now, example which can be taken over here is absorption of gas on charcoal, and in case of chemical absorption, you can take absorption of oxygen on silver or gold. Moving further, we can say why this absorption of solid or gas interface is important in pharmacy, why we need to learn this or understand this phenomena in pharmacy. First of all, it removes the objectable odor from the room, or you can say prevention of obnoxious gases entering into the body, or you can say mask. You can say if you need to estimate the surface area or particle size of any powdered material or solid material, we can use the phenomena of absorption. And specifically, you can say physical absorption because it is a temporary kind of, or you can say reversible phenomena. If you go for chemical absorption, it will again become irreversible. So that kind of determination will waste your product. Better we can go for physical absorption. Now, this is best explained by two best known scientists like Muir and Freundlich isotherms. So basically, to understand this phenomena of absorption, we need to firstly understand Freundlich. So what he tells is the variation in the amount of gas which is absorbed by the adsorbent with certain pressure at a constant temperature. Certain pressure and constant temperature can be expressed by the means of a curve, or you can say graph, that is also known as absorption isotherm. Now, as you can see in the equation, or you can see two equations, that is y is equal to, which is also termed as x upon m, which is amount of gas which is absorbed. So, Freundlich isotherms explain you the relationship between pressure of gas and amount absorbed at the constant temperature has been expressed. Now, we need, as you can see the first graph, you can see that y upon m is amount of gas molecule which is absorbed and P indicates the pressure. So as you increase the pressure, what happens is it will be constantly getting increased, forming a monolayer around it. Now, about multi-layer, it is a limitation of Freundlich. So as to create the, so as you can see the second graph, we have taken log for it to have a straight line equation. So slope will indicate amount of gas which is absorbed on the surface. Now, there is a limitation of Freundlich isotherm. According to Freundlich, only approximately explains the behavior of absorption. The value of 1 upon n, that is slope, can be between 0 to 1. Therefore, the equation only holds good for the limited range of pressure. So you cannot say at a higher pressure how will the molecule get or it will behave. That is the limitation of Freundlich. So moving further, we had seen Langmuir adsorption. So according to Langmuir, there is certain assumption which he has taken. So the first assumption is there is fixed number of sites which are present to adsorb. Now, second is the maximum adsorption. The gas layer is found around the solid is 1 molecule thick. You can say it is 1 molecule thick, or you can say a monolayer. Third, the rate of adsorption is directly proportional to the number of sites unoccupied. Of course, suppose this is a solid surface. So rate of adsorption can be determined the molecule which is the surface which is unoccupied. Suppose here it is occupied and here it is not. So rate of adsorption is the amount which is unoccupied. Similarly, we can say that the rate of desorption. What is desorption? Desorption is opposite of adsorption. So it is directly proportional to the number of sites which is absorbed, or you can say occupied. So according to it, there are certain types of adsorption isotherm which you need to understand. So there are 5 types of different adsorbent curves. Now, first 3 is for non-porous and this last 1 is for porous material. Now, first one, if you plot the graph between molecule adsorbed and pressure, the first type explains that as you increase the pressure, there will be the formation of monolayer around the solid surface. But after that certain pressure, it will become constant. You go on increasing the pressure, still the molecule will not have the space for occupying over the solid surface. Second one is, if you increase the pressure, it will behave according to the first one. It will form a monolayer. But when you go on increasing the pressure, it will start forming the multi-layer around it. Now, the third graph is between pressure and adsorbed molecule which is adsorbed. The third one explains that the molecules are randomly getting sticked over the solid surface. Suppose this is a solid surface. One molecule will be attached over here, second here, second here, second here. There will be no uniformity. You can say random arrangement of the molecules over the solid surface. Now, when you go on increasing it, what will happen? It will directly form a multi-layer instead of forming the monolayer first. In the first 2 graph, what is there? They are firstly forming a monolayer and then it is forming a multi-layer. But in the third graph, what is happening? Firstly, it is randomly getting arranged and then it is directly forming a multi-layer. Now the question is how? What happens is, here the rate of condensation is very much high. So instead of getting adsorbed on the surface, they are forming a multi-layer on the first molecule which is attached on the solid surface. So this is the difference. Now the fourth one is, again, what is happening? They are porous material. So in the porous material, there are pores which are formed. So molecule will not penetrate inside but instead form a monolayer around it. Now the next one is, the graph you can see is halfly, it is going straight line when you're increasing the pressure and then it is becoming constant. So what happens is, upon forming a multi-layer, what happens is the first molecule which are absorbed as a monolayer will start condensing and it will go into, or it will penetrate inside the pores and it will form again a monolayer around it. Correct? Now going upon the next last graph It is not forming any monolayer, instead it is getting arranged themselves into the pores. So in this video, you can understand or you can explain what is the difference between physical adsorption and chemical adsorption. You can also understand the importance of adsorption in pharmacy. Through this, you can understand the equation of Langmuir and Freundlich isotherm and understand the adsorption between porous and non-porous material by understanding the different types of isotherms. Thank you for today's video.